Hello, Integrated Math 1 students. Mrs. Robinson here to work Practice Benchmark Chapter 6 with you. Let's go ahead and get started. Okay, the first one, make a frequency table from the data. All right, remember with frequency tables, they need to be usually of equal size. They don't overlap, your intervals don't overlap, and don't have gaps. So you're going to make an interval from, or several intervals from this data. So let's pick our smallest data point that we're going to start with. So let's first look at our smallest data point here, and it looks like it's going to be 18. 18 is our smallest, and then look through your data points and see what your largest data point is. It looks like 31 is our largest, so that's our highest data point. So we're going to look at making a frequency table between 18 and 31. Now for me, I like to work by fives. So I would probably start with 15 and then go all the way up to 35. If I'm going to do that, to me, intervals of 5 make sense. You could do intervals of 4, intervals of 3, depending on how you want to do it, but I like to work by 5. So I'm going to make my first interval be 15 to 19. Now careful, if you're working by intervals of 5, you want to keep that same interval going. So from 15, you might think 15 to 20, but you have to count 15. So 15, 16, 17, 18, 19, that's 5 data points. So I've covered 19, then I'm going to start with 20 and go to 24. And I've covered 24, so I'm going to start with 25 and go to 29. I've covered 29, I'm going to start with 30 and go to 34. And that does cover all my data points. So technically I'm not going all the way till 35. So making my frequency table, I'm going to have a weight here. And then I'm going to have my frequency. So I've made intervals, and I'd like to know how many of my data points fall in this first interval, the second interval, the third interval, and the fourth interval. So let's go ahead and count it out. How many of my data points fall between 15 and 19? You're just going to go through and count and say 1, 2, 3, 4. 4 fall between 15 and 19, and then do that for 20 to 24, 20. So if we go ahead and go 20 to 24, I've got 1, 2, let's see, 3. So I've got 3 between, and then 25 to 29, I've got 1, 2, 3, 4, 5 in that data point, or in that grouping. And then 30 to 34, I've got 1, 2, and I've got 2 here. So just make sure everything is covered and you've got equal groupings here and they're not overlapping. So you can't have 15 to 20 and then 20 to 24. That would overlap because where does 20 go? Does it go in this grouping or this grouping? So just be aware of that. Okay guys, number 2, we're going to make a histogram from this data set. Before we make a histogram, let's make ourselves a frequency table so we can do an accurate histogram. Let's go ahead and look at, this is going to be the price. So let's do the price here. And how often does that occur? Frequency. Okay. Let's go ahead and look at our smallest data point. Looking through these, it looks like 3 is our smallest data point and 12 is our largest. So unlike that last grouping, our grouping is tighter together. So instead of going by 5s, I think I'm going to go by 3s here. Let's do 3 data points in each frequency, in each grouping. So I'm going to start here with 3 and go to 5. Or actually, let's start with 1 just to make it even. Let's start with 1 and go to 3. Now that's 3 points. Now remember, I don't want to overlap and I want to keep my data points in my groupings even. So I'm going to start with 4 and go to 6. I don't want to overlap, so I start with 7 and go to 9. Once again, I already have 9 here, so I start with 10 and go to 12. So my groupings are even. All right, now let's go ahead and look at how many times my data points occur in each grouping. So from 1 to 3, I've got 1 point, just 1 point. Okay, from 4 to 6, I've got 1, 2, 3, 4. I've got 4. From 7 to 9, I've got 1, 2, 3, 4, 5, 6. And then from 10 to 12, I've got 1, 2, 3. All right, now this will help me set up my histogram. So I'm going to set up my histogram like this over here. And I want to keep my bars even. So my intervals are even groupings. So I'm going to go 1 to 3 here, and then 4 to 6. That's not 4 to 6, 46. 4 to 6, 7 to 9, and then 10 to 12. All right, it's hard to make my pen work there. Okay. There are my groupings, and up here is my frequency, F-R-E-Q-U. Okay, so with my frequency, since I can't draw to the side with this pen, I have between 1 and 6, so I'm just going to go by intervals of 1, 2, 3. Let's erase this, make it prettier. 3, 4, 5, and 6. So from 1 to 3, the frequency that happens there is 1. So here's my histogram. All right. Between 4 and 6, I don't know I did that. Push something weird on my pen there. All right, between 4 and 6, that happened 4 times. There are 4 data sets between 4 and 6. All right. So how wide my bar is should be the same because there's 3 data points in each, but how often that occurs, it occurs 4 times. Between 7 and 9, that occurs 6 times. So I'm not overlapping, we're just touching. Each bar should be touching, okay, because we go from 6 right to 7, and then 10 to 12, that happens 3 times. So right here at 3. And they should be even though I'm drawing this freehand, it doesn't look super even, and that's what that should look like. All right, tell whether this histogram is uniform, symmetric, or skewed. Now, to me, this looks pretty symmetric. This one's a little bit bigger than this one. I mean, if it was completely symmetric, it would be like this, and this one would be down here to be exactly symmetric, but it looks pretty symmetrical. I'm going to pick symmetric here. It kind of goes up and then it goes down. Now, a skewed graph might look something like this. A skewed graph might have a bunch of data points all on one side, okay, where these were all high and this was high and then these were really low. If my data points look like, well, let's erase this. If my data points look like this, and then it was big on this side, I would say it's skewed to the right, okay? And a uniform might look something like this, where they all were kind of about the same height, okay? Where everything was kind of about the same height. That would be more uniform, maybe up like this, okay? This one to me, though, looks symmetric. I'm going to pick symmetric. All right, a cumulative frequency table really isn't that different from a regular, except for you're going to add an extra column. So remember, you should have 3 columns, okay, with cumulative frequency. Okay, let's look at your data points. It looks to me like 1.1 is your smallest data point, and it looks like 6.1 is your biggest data point. So looking at how we want to group these, I know for me the easiest way to group these might be just from 1 point. Since we're dealing with decimal places, and you can have multiple data points within, like 3.15 and 3.5 would be within that one point. So let's go ahead and do 1.1 to 2. And then let's go 2.1 to 3, 3.1 to 4. And we're going to go all the way to 6.1. 4.1 to 5, 5.1 to 6, and then 6.1. We have to continue this one to 7 because that's our biggest point. Now you could have done this a variety of ways. You could have done like 0 to 2, 3 to 4 by 2s. This is just one way to do it, all right? So here's our weight, and we need 3 columns. We've got our weight, we've got our frequency, and then let me erase this so I have a little room. We've got our frequency, and then we need our cumulative frequency. Okay, so make sure you've got 3 columns. You've got your weight depending on how you've grouped it and what intervals you used. Then you need to show me your frequency and your cumulative frequency. All right, so let's go ahead and look at this. Our frequency from 1.1 to 2. We've got 1.2. Let's see, do we have any other data points? Looks like we've got 2 data points. Let's go ahead and do our frequency, and then we'll worry about the cumulative frequency column. Oh, whoops, I put that in the wrong spot. Hold up, sorry. Let me go ahead and fix that. This was my column titles. All right, from 1.1 to 2, we've got 2. 2.1 to 3, let's look at that. So we've got 1, 2, we've got 3 of those. 3.1 to 4, we've got 1, 2, 3 of those. 4.1 to 5, we've got 1 of those. 5.1 to 6, we've got 1, 2 of those. And then 6.1 to 7, we've got 1 point. Now that's my frequency. Cumulative frequency is literally accumulating how many data points I've got all the way down the row. So I start with 2. Then by the time I get to here, I add on 3 more. So now I've got 5. Now I'm going to add on 3 more. So now I have 8. Add on another one, I have 9. Add on 2 more, I have 11. Add on my last one, I have 12. So I have 12 data points, and you should have 12 data points here. So make sure you count them out. This should be the number of data points you have total. So you just count them up as you go. You start with 2, and then you add on more and more, and that's your cumulative frequency. All right, and that's all you have to do. So basically, when you get to your cumulative frequency, how many times did the data points occur all the way up to 6.1 to 7? Well, everything better happen by 7. All right, guys, this is just reading your histograms. This should be pretty straightforward. The histogram shows the amount of gasoline that 80 drivers bought to fill their car's gas tank is shown here. So this is the gasoline purchase. This is the number of drivers and the number of gallons, okay? So 0.1 to 3 gallons, the number of drivers that did this. This would be the frequency. How many drivers did that occur for? How many drivers does this occur for? So which interval represents the greatest number of drivers? So the number of drivers are here. Just look at it. It looks like it's going to be this interval, 9.1 to 12. So this should be a pretty easy problem. Just read the histogram. How many drivers bought more than 12 gallons? Well, let's look. Where do you get to 12 gallons? More than 12 gallons, not 12 gallons itself. So more than 12 gallons occurs right here. Okay, this is where that occurs. This is 9.1 to 12. So more than 12 would be anything this way. So how many drivers did that? Well, in this interval, it looks to me like you've got halfway between 16 and 20. So this interval looks like about 18 drivers here. Here in this interval, you have 12 drivers. So we're going to add on 12 for that interval. And in this interval, it looks like you're almost to 8. So I'm going to go with 7 or 6, maybe halfway. Okay. So if you've got this many drivers, you've got 18 here, 12 here, and 6 here. So add those up. How many do you have? 36 drivers. All right. How many drivers bought 9 gallons or less? So go to where there's 9 gallons right here. This is the 6 to 9 interval, or less. So basically we're just adding up these 3 intervals. So in this interval there were 12. Here there's 8. And here it looks like about halfway. So I'm going to go with 2. So we're just going to add these up. Add all these up. 12 plus 8 is 20 plus 2 is 22. So about 22 drivers did that. All right, let's look at number 8. Number 8 asks us to find the mean, median, mode of this data set. And it's an average rate, revolutions per second. So mean, remember, mean is the average. So if you ask for your average test scores or your average for all the tests that you've taken, you add up the number of tests that you've taken, you add all that data set up, and you divide by the number of tests. Median is the middle number. Median, think middle. And then mode is the number that occurs the most. So remember, mode, M-O, is most. Mean is average. Middle is the median, mode is most. So if we want to first find the mean, I have to add up my data set numbers. So I'm going to add these all up, 75 plus 81 plus 79 plus 68 plus 79, and divide by the number of data values. 1, 2, 3, 4, 5. There are 5 of them. 1, 2, 3, 4, 5. So just go ahead and do this on a calculator. Add these up and divide by 5. So if this was an average, you should get 76.4. And that would be your average test scores. That would be your grade for if your grade was based on test scores. If you had a test score of 75, 81, 79, 68, 79, and you were going to get your final grade would be 76.4, which is a C. All right, now let's go to middle or median. Okay, your median, you need to line up your numbers in order from least to greatest to get your median. You can't just look at this and pick out the middle number. They need to be from least to greatest. So we're going to go 68, then the next one would be 75, then you would go 79. Let's just cross them out to make sure we've covered them all. 79, then 79 again, and then 81. Now I've written them in order. Now, because I have 1, 2, 3, 4, 5 numbers, my median or my middle is just the middle number. Now, if I had 6 numbers, an even number, I would have to find, let's say there was another number down here, a 60. I would have to find the average of these two. I'd add these together and divide by 2. But when there's an odd number, it's easy. It's just the middle. So the median is 79, right? And the mode, the number occurs the most, is, once again, 79. So make sure you tell me the mean, the median, and the mode. All right. Find the value of x so that this data set has the given mean. So here's the mean. So this is the average. But I have one data value I don't know. But I know when I add these all together and divide by the number of data points, I get 88. So this might be what you do if I got 77 on one test, 100 on another test, a 92 on another test, and 84 on another test. I've got one more benchmark to take. This will be my 5th benchmark. And I want to know what I have to get on that benchmark if I want to get an 88. And you might do a 90 here, because what do I have to get on this benchmark if I want to get an A? That would be more likely what you would do. But let's go ahead and go 77 plus 100 plus 92 plus 84 plus a data value I don't know. And how many data points do you have? 1, 2, 3, 4, 5 data points, or 5 test scores. And you know your average is going to be an 88, or that's what your goal is. I want to get a high B. So figure out what that has to be. Add these all up. If you go ahead and add these all up, 77, all of these numbers plus x, you're going to end up getting 353. That's this all added together, plus x. And you're going to divide that by 5. And that's still equal to 88. So what you just have is a little algebra problem. Add these all up, plus x, divide by 5, that equals 88. So I've simplified. Now, to get rid of a division, this whole thing is divided by 5. So I can go ahead and get rid of it by multiplying both sides by 5. Doing a little algebra here, multiply both sides by 5. That eliminates the 5 on this side, and you're left with 353 plus x equals 88 times 5 is going to be 440. Now to solve for x, this is an addition, so do a subtraction. 353, subtract from both sides. And you're going to end up with x is going to be 87. So that data value is 87. If you want to end up with an 88 average, you need at least an 87 here, or you need an 87 here. Now, a more realistic thing would be to do a 90 here so that you can know what I have to get on the test to get an A in the class. Okay, they want us to compare these two sets of data. They want to know the range, how wide is this data spread out, and then the average. Then we're going to compare the two sets of data. What do we notice? So let's do set C first. Set C, okay. So the range, we need the range and the mean. We're going to do set D, and then I'll just write this out. We need the range and the mean for set D. Okay. So looking at set C, let's look at our lowest data point, which is 3.7. And then our largest data point is 9.2. So the range would just be the difference between the largest and the smallest data point. So I'm just going to subtract those, and I get 5.5. So the range of set C is 5.5. So from the smallest to the largest. Now let's do the mean for set C. So I'm going to add up all my numbers. I'm going to go 5.6 plus 4.8 plus 3.7 plus 7.1 plus 9.2 and divide by the number of data points, 1, 2, 3, 4, 5. So just do this on a calculator. Add these up and divide by 5. All right, if you add these up and divide by 5, you just get 6.08. So there's your range and your mean for set C. Now let's do the same thing for set D. Let's go ahead and find our range and our mean. Our range for set D, let's look at our smallest data point. It looks like it's 2.9. And our largest data point looks like it's 10. So the range would be 10 minus 2.9. All right. So the range for set D is going to be 10 minus 2.9 is 7.1. Now let's look at our mean. We're just going to add them up. So the mean is just going to be 10 plus 5.2 plus 3.8 plus 2.9 plus 6.8. And how many data points are there? 1, 2, 3, 4, 5. There's 5 data points. So divide by 5. And that was the slantiest line I've ever made. All right. Go ahead and do this on a calculator, and you should come up with 5.74. All right, so we've got the range and the mean of each. Now answer the last question. So you need to give me both of those for each data set. The range and the mean for set C, the range and the mean for set D. Now compare the two sets. If you look at set C, it has a smaller range, but it has a larger average of numbers. So the range, the numbers are closer together and they have a bigger average. Here with set D, the range, the numbers are further apart and it has a lower average. So what this would mean if this was a quiz score and I was looking at class 1 and class 2 would have a student that did really well on the quiz and a student that did really poorly. So the average would be lower. The range that is spread apart, further apart. Class 1, their lower score isn't quite as low and their highest score isn't quite as high. So class 1 did collectively better on the quiz. They didn't have somebody that did as poorly, but they didn't have somebody that did as well. The range is smaller and it brought our average up a bit. So I would just say set C, and that doesn't say set. Set C has a smaller range and bigger average than D. All right? And that would tell you something. If that was class quiz scores, that might tell the teacher something about how each class did. Let's go on to number 11. We're going to find the mean, median, mode, range of each set of data after we perform the given operation to each data value. Careful. A lot of students miss this because they don't do the after you perform the given operation. So first I have to add 3.5 to each data point. So doing that, if I add 3.5, this becomes 19.7. This becomes 20.2. This becomes 19.6. 16 becomes 19.5. And I'm just writing them out a little further. 16.9 becomes 20.4. And then 16 again becomes 19.5. So now I'm going to find the mean, median, mode, and range. Okay, after I added 3.5. So make sure you answer the question. So looking at the mean, I'm going to add these all up and divide by 1, 2, 3, 4, 5, 6. So I'm going to add these all up and divide by 6. Go ahead and do this on a calculator. Add these all up and divide by 6, and you're going to get a mean of 19.8. Okay, the median is the middle number. In order to get the median, come down here or over here on the side. Make sure you write these in order from smallest to largest. So I'm going to have to go 19.5 is my first point. Two of those, 19.5, then a 19.6. Then we have 19.7. Then we have 20.2 and 20.4. Just check you have 6 data points, 1, 2, 3, 4, 5, 6. The median is the middle number. So halfway would be right here. There's not a middle number, so I have to find the average of these two. I have to add together and divide by 2. So when I do that, I'm going to get 19.65. Okay, add these together and divide by 2. Between 6 and 7 is 6.5. Okay. All right, the mode is the number that occurs the most. Look at the number that occurs the most. 19.5 occurs twice. Nothing else occurs twice, so that's going to be your mode. And your range is the difference between the smallest and the largest. So I'm just going to go 20.4 and subtract off 19.5, and that difference is 0.9. And you can have a 0 there if you want, 0.9. All right, so there it is for this one. Now for this one, I have to multiply by 2. So let's go on to number 12. First, multiply everything by 2. So if I do that, this point becomes 15. This is 28.4. This is going to be 23.6. 19.6 turns into 39.2. 4.8 turns into 9.6, and 11.8 turned into 23.6. All right, so we need to find our mean, our median, our mode, and our range. Okay, our mean, I'm just going to add these all up and divide by the number of data points. 1, 2, 3, 4, 5, 6. 6 data points. So add these all up in a calculator, then divide by 6. That mean, when you do that, should give you 23.23. Median, you need to have these in order from least to greatest. So let's go ahead and write these in order. So I'm going to start with 9.6. Then I'm going to go to 15. My next data point would be 23.6, which occurs twice. So I can tell that's probably going to be my mode. Then I'm going to go to 28.4. Then my last one would be 39.2. Okay, so let's go ahead and find the median. The middle number is halfway between. There's 3 data points this way, 3 this way, so this is my middle number. So I'm going to have that right there, and it's the same number. So I don't have to average them. It's just 23.6. Right. The mode is the number that occurs the most. Once again, 23.6. The range is the difference from the greatest to the least, so I'm going to go 39.2 and subtract off 9.6. And when I do that, I'm going to get 29.6. And there's your solutions, okay? Now make sure you do the multiply by 2 first and get your new data points before you do all of this. That's the biggest mistake I see on these. Okay, guys, let's go to 14. Find the minimum, first quartile, median, third quartile, and maximum for this set of data. And the reason we do that is to make the box and whisker plots. And you can look at sets of data and see how they're skewed or how they're clumped together. It's helpful for looking at data for doing this. So in order to do this, you need to make sure that you order your numbers from least to greatest. So let's start there. 19 is our first number. So we're going to go 19, then 22, then 24, then 25, 27. This is super boring. I'm going to pause it and finish it. Okay, so I wrote the data sets from least to greatest. Please do this before you work any of this. And then I cross them out to make sure I don't miss anything. Okay, if you want to come and erase all your markings, you can. Now that I've done that, I can find the minimum. Well, here it is. 19. So the min is 19. Now the first quartile, median, and third quartile. I'm going to chop this up. How many data points do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 data points. Now the first thing you want to do is find the median, okay, the middle. So if there's 9 data points, there's going to be 1, 2, 3, 4 on this side, 1, 2, 3, 4 on this side, and the one right in the middle will be your median. Okay, because it's an odd number, you find the one on the middle. There's 4 data points here, 4 data points here. So the median or the middle is 27. The first quartile is the median of the lower half, not including this median point. You don't include this median point. Unless that median point has to be halfway between, then you can include that point. But we don't include it here. We're just going to find the middle of these lower half. Of this lower half. The book sometimes includes it and sometimes it doesn't. You really aren't supposed to include it, okay? So we're going to find the middle of the lower half. So the first quartile, okay, is going to be between these 2 data points, between 22 and 24. So I'm going to find the average of 22 and 24. I can add them together and divide by 2, or I can just see between 22 and 24 is 23, all right? So that's my first quartile. Third quartile is the median of the upper half of data, not including this. Now, if it was an even set of data and I found the average between, I would have a point right here, and then I would include that, but not in the odd set of data. So the upper half would be between these 2 points. So between 32 and 33, it's going to be 32.5. If you're not sure, add together, divide by 2, you'll get 32.5. So that is the upper half's median. So the median is really your second quartile, okay? You got your min, your median, your first quartile, your third quartile. The median is the second quartile. And the max is just your biggest number, and if you write them from least to greatest, that's simple. It is right there, 35. All right? Are there outliers? Not in this set of data. They look pretty close together. All right, we're going to make a box and whisker plot to represent this set of data. We have to do all of those numbers that we just did in that last one. So let's write our data set in order from least to greatest. So let's start and go 55. Oh, I need a pen. Hold up, wait a minute. We'll go 55 and then, let's see, 68. And this is really boring. 78, it looks like is, nope, 77 is next. Then 78. And I'm going to pause it and finish this. All right, here's my data points written out. Let's go ahead and find our quartile 2, or our median, okay? Our median. And we'll start there. So there are 1, 2, 3, 4, 5, 6, 7, 8 data points. So our median is going to be halfway between the 4th and the 5th point. So I'm going to find the average of these two, add them together and divide by 2, and it's going to give you 79.5. That's going to be your quartile 2, or your median. Now, we're not going to include that median, but we are going to include this point. So here's the whole lower half. I just don't include the median. Here's the whole lower half. There are 4 data points. So my middle, or my median of the lower half, would be an average of these two. So add these together, divide by 2, and you should get 72.5. That's your quartile 1. Now the upper half are these 4 data points. So the median of the upper half would be between the second and the third point here. Add those together and divide by 2, and you should get 89. So that's your quartile 3, all right? Here's your lowest point, and here's your highest point. Don't really think any of those are outliers, so we're going to go ahead and use them. And let's go ahead and draw ourselves a box and whisker plot. So draw yourself a straight number line. Make sure you label it so that I can see your points. Your middle point or your median, make sure you just label it in even increments, all right? So let's just go by tens, 50 to 90. So let's start here at 50, 60, 70, 80, 90, 100. So we'll go 50, 60, 70, 80, oh, I put 78, sorry, 70, 80, 90, 100. All right, and let's go ahead and make our box and whisker. Our median is at 79.5, so almost to 80 right here. Now I'm going to draw a line through that data point. My upper quartile is at 89, almost to 90, right about there. And I made that super curvy. Nope, I can't. Let me see if I can just do it like this. There we go. No, it's not going to draw. Okay, and then my lower quartile is 72.5, so a little bit above 70, right about here. And I am drawing this freehand, so all right, there is the data values I need to make my box. So my box is a little slanty there, but there's my box. And that is where the middle parts of my data lie. This is my inner quartile range, okay? Then I'm going to take it all the way to my upper point, which is 79, right, for 100. And that will make my upper whisker. And then all the way to my lower point, which is 55, right about here. And that will make my lower whisker. So the lower quarter of the data is here, the upper quarter of the data here, the middle set of data is right here. So you can see this is more dispersed in the lower half than in the upper half. All right, and there's your box and whisker. All right, let's look at 16. We're going to talk about percentile rank. Remember percentile rank, percent means per 100. Percentile rank is the percentage of data values that are less than or equal to that data value. So if I say you're in the 90th percentile for height, that means 90% of the people are shorter, are either your height or shorter, okay? So whatever the better thing is, the 90%, everybody else will have a smaller value than you, okay? If 50 babies are born, so that's our total, that's how many we have, all right? That's our 100%, that's our 50 babies. 5 of them weigh more than 10 pounds. So 5 weigh more than 10 pounds. If 5 weigh more than 10 pounds and there's 50 babies born, that means there's 45 that weigh 10 pounds or less. Okay. So what's the percentile rank of a baby that weighs 10 pounds? Okay. If 5 weigh more than 10 pounds, 45 of them weigh 10 pounds or less. Remember what percentile means. Percentile, you want the percentage of data values that are less than, okay, or equal to your value. All right. So the baby that weighs 10 pounds, how many of them are there? There are only 5, but we want the value, the percentile tells us the values that are less than or equal to your value. There are 45 that are 10 pounds or less. So we want to know the percentile rank of a baby that weighs 10 pounds. Well, I'm going to take the value that is less than or equal to my value, 45 of those, and divide it by my total value, 50. So 45 of them are 10 pounds or less. This is going to give me my percentile rank. So if I do 45 divided by 50, I'm going to get 90%. So a baby that weighs 10 pounds is in the 90th percentile. That means 90% of the babies are 10 pounds or less, which is probably accurate. 10 pounds is a pretty heavy baby, Okay, so that's the percentile rank, the 90th percentile. And you'll hear that a lot with test scores. I scored on my standardized test in the 50th percentile. That means half the people scored worse than me. Okay, so it's the value or less. Just want to give a hint for people that are watching this. On number 16 on the test, asks you about percentile rank, but they're going to give you a value for a race running less than or equal to 20 minutes. Just this is the hint. Remember, if you run under 20 minutes, you're actually doing better. If you run slower than 20 minutes, like you run 21, 22, that's actually worse. So usually percentile rank is the people that do yours or worse. So think about that, yours or worse, yours or less than. But in this case, less than with the 20 minutes on that actual test question is actually better because it's better to run in the shorter amount of time. All right, looking at number 18. If you notice there is no 17, that was a mistake. It's okay. I'm not going to mark off that point. It's like a freebie point. Okay, this should actually say 18 to 19. Okay, because you're going to get 2 points. One to make a scatter plot and one to describe the type of correlation. So make your scatter plot. Just draw it out by hand like this. Okay, make an L, and you're going to have like your X and your Y. Let's make foot be my X, so foot size will be here. And then your height can be your Y. And let's write that a little nicer. Okay, so your height will be your Y. Your foot size goes from like 6 to 13. Let's try increments of 2 and just see how that goes. 2, 4, 6, 8, 10, 12, and then we'll go all the way to 14. And then your height is in inches. It looks like the lowest is 61 and it goes up to 70. So just to scale this, okay, let's go by 5s maybe. No, that will be too much. Let's go by 10. So we'll go 10, 20, 30, 40, 50, 60, 70. And that's super smushed. Okay, now make a scatter plot. You literally just label your X and your Y axis and label your points and just draw your plot. I just want to know, can you plot these points? If the foot size is 10, the height is 70. So I'm going to go over 10 and up to 70. So the data points are going to be all clobbed together because of how I have my height so close together. All right, if you have a foot size of 13, your height is 77. So here's between 12 and 14 will be 13. And 77 goes almost, all right, 10 should be down a little bit more. Sorry. It should be here. And then 13 all the way up here to 77. 8 will be at 66. And this is not very accurate. I apologize. This should be up a little more. Let's try this again. 10 and 70 right here. All right, 8 and 6. So I go over 8 up 66. I go over 6 up 61. So right about there. And then I go over to 11 and up to 72. So 72 is right about here. Okay. So looking at the scatter plot, I've drawn my data points the best I can because I drew it freehand. So I made my scatter plot. Now I want to describe the type of correlation. Does foot size relate to height? Well, I'm going to say yes, because the bigger the foot size, the taller the person. What kind of correlation is it? It's positive correlation. So make sure you tell me what kind of correlation it is. Describe the type. So if the data points all went down, that would have been negative correlation. If the data points were everywhere, that would have no correlation. This has a positive correlation. As foot size goes up, height goes up, and it looks positive. It's going uphill. Okay, guys, for the last, 6 problems, make sure you review lesson 6-5 and what are your frequencies mean. Make sure you know what joint frequency, marginal frequency, joint relative, joint frequency, marginal frequency. Make sure you know what those not means. What's these means? So I can't talk. So here's your margins. Think of it like you're writing in the margins. This is your table, okay? So remember, when you're looking at a table, this is a joint frequency. These 4 are joint because they're joint with 2 things. I exercise and I play a sport, okay? These are your marginal frequencies. They are in the margins. These are your marginal frequencies. And then this would be your grand total, okay? This is your grand total. So marginals, joints, grand. So if I'm looking at a joint frequency, I'm just looking at one of these. If I'm looking for a marginal frequency, I'm looking at one of these, okay? If I'm looking for a joint relative frequency, so you're going to divide a frequency by the total in the row or the column, okay? Joint frequency, one of these, okay? Marginal frequency, one of these. So just be careful and make sure you know what you're looking at. If I'm looking for a conditional frequency, okay, a conditional frequency is when that's a little bit different. Make sure a conditional relative frequency, you would take your joint frequency and divide it by a total in one of these because it's conditional for this row or for this column. So make sure you know those. So let's look at this. How many students took part in the survey? That's your grand total, 250. What's the joint frequency of the students who play a sport and prefer to exercise on the weekend morning? So first look at the students, look at it in order. Who play a sport? So I'm going to go to where they play a sport. Yes, they play a sport. So let's look at that row where yes, they play a sport. It's this row, okay? How many students play a sport and prefer to exercise on weekend mornings? Right here, play a sport and exercise. So 40 of those. That's the joint frequency, all right? Let's go ahead and look at 22. What's the marginal frequency? So we're to the margins, okay, of students who don't play a sport. So I'm going to go to place a sport and no. Let's look at the marginal frequency, 140. Okay, 140 of those. All right, that's how many do it. I didn't ask, hold on a second. I didn't ask for, just make sure you realize I didn't ask for the marginal relative frequency. That's where I would take this and divide it by the grand total. I just asked for the marginal frequency, just right here in the margins. Joint frequency right here. Okay, now look here. It's asking me for, I lost my pen. What's the joint relative frequency? That's where I'm going to divide by their grand total, okay, because it's relative to how many people I surveyed, right? The joint relative frequency, so I'm going to go to the joint frequency, it's here, and divide it by the grand total, relative to how many people took the survey. So I want the joint relative frequency of the people who played a sport and prefer to sleep in. So I'm going to go play a sport, prefer to sleep in, right there at 70. So they are 70 of them, but it's relative to how many people took the survey out of 250. Divide by the grand total, okay? So you can give me a 70 out of 250, or you can go ahead and give it to me in a decimal, 0.28. Okay, so 28%. All right, let's go to 24. What's just the joint frequency, not relative, just joint, of students who don't play a sport and prefer to sleep in on weekend mornings? So I'm going to go to play a sport, no, and prefer to sleep in right here. So that would be 85. All right. And then let's go to number 25. And I'm going to have to clear this off because I had to scroll down. What's the marginal frequency? Didn't say margin. It didn't say marginal relative, just marginal. Okay. What's the marginal frequency of students who prefer to exercise weekend mornings? Okay, so I just have to go margins. Remember, here on the margins, let's just make our margins. Okay, I'm just going to go to the margin where the exercise is. Here's the exercise, and here's the margin. Okay, 95. Now, if it was marginal relative frequency, I would take 95 and divide it by how many people there were. But it's just marginal frequency, and you're done. All right, guys, I'm going to give you one more hint since we didn't do a conditional relative frequency. Okay. Let me give you an example because there is a conditional relative frequency on the test. Okay. So conditional, I'm going to write this, conditional relative frequency. I can't even write it. Okay. If you have a conditional relative frequency, remember what, okay, that means you're just dividing your joint frequency, one of these, by whatever the total of the column or the row is, depending on the condition. So let me give you an example. Okay, so here's an example of conditional. Conditional relative frequency. Remember, just just joint frequency or marginal frequency is the number. When you do relative, you do it relative to the total, unless it's conditional. So when you do a relative, think I have to divide by the total, whatever the total is. Except for if it's conditional, that's a different story. Conditional is conditional just to the row or the column. So whatever row or column is given, that will be your relative total. So given that they exercise, I'm going to look at the exercise column. This will be what I'm going to divide by. That's the total number of students I have that exercise, 95. Okay, if I was given that a student plays a sport, okay, that would be this column. But no, I'm given that they exercise, or sorry, that would be this row. I'm given that they exercise. So remember, relative means a divide by total. Okay, just remember that's what relative means. Anytime you see a relative in one of the problems, you're going to divide by the grand total, usually. Okay. Relative means you divide by the grand total, unless it's conditional. Okay, then you just divide by the column or the row it's in. Okay, whatever's given. So in this case, we want the conditional relative frequency that the student plays a sport. So they play a sport, so one of these, given that they exercise. So here's plays a sport and exercise. Now what am I going to divide by? Am I going to divide by that total or this total? You divide by what you are given. You're given that they exercise. So if that's what you're given, this is what you're going to divide by, this total. This is the number of students that exercise total. Okay, that's the yes and the no. So this will be the total number of students that are surveyed on this question. And we're going to take our conditional relative frequency would be that a student plays a sport given that they exercise. 40 of them do that. So that would be 40 out of the total that were surveyed about exercising, 95. Okay. And 40 divided by 95, and you can put this as a decimal and just divide these out and put it at a decimal or a percentage. So if I did, let's see, 40 divided by 95, I'm going to get 0.421. I just round to 0.42 or 42%. So 42% of students play a sport given that they exercise. All right, so make sure you know that the given is the column or row that you get your total from. And then relative means divide by the total, usually this, unless it's conditional. All right, and good luck, guys. Let me know if you have any questions. Send me an email.